Hello everyone and welcome to Learn It Up. Today we'll be starting a new chapter that is vectors, and this video will be all about introduction to them. So first of all, let me write the heading vectors. So what are vectors? A vector is a physical quantity that has a magnitude like all physical quantities. But the thing that makes it different from all other quantities is that they have directions as well. So directions. So let me give you an example. Imagine a vehicle is going with a speed of 5 meter per second. So as you can see, this has only the magnitude, but if we write so but if we write this as like 5 meter per second to the north, so this will be, let me just change the color, so this will be a vector, while this other one that had only the magnitude will be scalar. So what's the difference between a scalar and a vector quantity? It's simple. Vector has a magnitude and direction, so direction, while a scalar has only magnitude. Okay, so now that you know what a vector and a scalar is, we can jump into the basics of vector arithmetics. So first of all, the thing that we are going to see is vector addition. Let me just write it up. Vector addition. So before we go deep into this, let me first show you how we represent a vector. So suppose this is a point that is going with a velocity of 5 meter per second to the right. So the line and the arrow that you see there will be a vector. That is a linear representation of a vector, and to symbolize it, let's call this particle A. So to symbolize this, we write it as A with the arrowhead on top. So this A will be a vector. So it will have an arrow on the top, so you'll know that it's not just any physical quantity, it is a vector. So okay, so now that you know how to represent a vector, we'll go into vector addition. So basically, vector addition is like, well, let's suppose that this is a particle A and this is a particle B, and these are all vectors, both of them. So let me just change the color. Okay, so to add both of these vectors, what we do is just like, let C be the resultant vector. So to add them, we just write C is equals to A plus B. Okay, so that was not very creative, was that? So this is just the basic of the vector introduction that we are learning now. So if we get a question like add these vectors, you'll know what to do, and you'll know that we just have to add the magnitudes of the vector to get your resultant vector. So now the next thing, which is a very important thing, is component of vectors. Let me just write it down. So what's a component of a vector? A component of a vector is just like a projection of that vector onto an axis. So let me just draw it. This is an A vector, and let these be the coordinate axes. This is the X and this is the Y. So to make projection of this vector, let's say we'll project this on the x-axis, so we make a line here, and so this part that you see, this part, the length of this part will be the magnitude of the component of the vector on the x-axis. So let's say this vector has a magnitude of 5 meter per second or anything, and the angle that it makes from the x-axis is 60 degrees. So with basic trigonometry, if we know the formula of cosine, so cos 60 will be this part, the red part, let's mark it as x. So it is, cos is base upon hypotenuse, so the base is 60, sorry, x, and the hypotenuse, that is the magnitude of that vector, is 5. So if we find x, it will be 5 cos 60. So this thing that we just found out, this x, it is the component of the vector on x-axis. So this is the component on x-axis. Similarly, we can find it on the y-axis by just using simple trigonometry. So this was our coordinate axis, and this was the vector. And if we use simple trigonometry and join this vector to the x-axis, so this will be, this will be the component. So now that this angle is 60 degrees, this one will be 30. Okay, so let's find the value of y. Y will be, let me first, okay, so sine 30 in this triangle, this one, I don't know why it keeps disappearing, but in this triangle, sine 30 will be equal to, not sine 30, what am I doing, cos 30 will be equal to the base, that is the y component, and the magnitude of this vector. So y will be y cos 30, and if we use basic trigonometry here, 5 cos 30 can be written as sine 60. So with one angle, with only the 60-degree angle, we found both the x component of the vector and the y component of the vector. So if we want to represent this, let's say it is a vector and its x component is 3 and its y component is 4. So we can represent that a vector into its components, which is basically 3 and 4. Now let's say you get a question and you're given the components, x and y components of that vector. You can basically solve them to get the main vector whose components you have been given. So like, for example, let me draw the x-axis again and the y-axis. So this is the x, this is the y, and you have been given this x component, which is, let's say, 3 meters per second, and the y component of a vector, let's say 4 meters per second. So now you have to find the resultant vector or the main vector whose components you have been given. So that is very easy. It's just like the Pythagoras theorem. You just take the root of the x component squared and the y component squared. So in this case, the x component is 3 squared and the y component is 4 squared. So we get an answer as 5 meters per second. Okay, so this was how you project a vector into its components, and you can find out the main vector if you have been given the components. So this was all the basic introduction to vectors. Using these things we can basically find out very in detail about the vector given. And in the next episode we'll probably do some questions on these components of vector and get more deeply and study deeply the vectors and what are they and how are they useful in real life. So thanks for watching, guys. Please like and subscribe, and I'll come back to you with the next episode. So that's all for this. Bye.